Good morning to all. I am Dr. V. Rukkumani, working as an associate professor in the Department of Electronics and Instrumentation Engineering at Sri Ramakrishna Engineering College. We are going to see about Flux.AI, which is used to design any complex circuit. It can be converted into a PCB, and the same any complex circuit. It can be converted into a PCB, and the same circuit can be converted into a Xilinx coding. Once we go to a Flux.AI, we can create our user ID and login name, and they send a mail. Welcome to Flux. Now we go to Flux platform. Here we are having login page. In this, plenty of tutorials and examples are also available. We can go with our registered mail ID for creating an account. So now the dashboard is ready. Here I am creating five projects. So this is my profile. We can edit our profile whenever it is necessary. Now we move on to what are the components available and what are the features available in the Flux. So here we can go for create an organization, documentation, tutorial, featured projects, community. Now we move on to tutorial session. Here example circuits are there. So set up a Flux. How we can go with this Flux for circuit design, and first from this circuit how it can be converted into a PCB. Components and modules available in PCB layout, and the components and the modules are available in normal breadboard connection, PCB layout, PCB manufacturing. All these are available in the same platform. Now we move on to set up a Flux. Firebox or Google, we can use the module. So first creating an account is completed with the Gmail account. Now we move on to tutorials. Components and modules, schematics and simulations present in the PCB. A simulator is available, and how we can simulate the circuit. We have a small videos, and how the simulated circuit can be converted into a coding. It is also available. And finally the circuit diagram. Once the circuit is created, this is circuit diagram and the created Flux model circuit diagram here. Here we can change the value of resistor, capacitor, and the op-amp can be modified and simulated with various frequency, time period, etc. And finally output will be displayed. Now we move on to design a simple circuit. Want to create a new project. Here we are having a new project. These are the sample projects are available. If I want to connect, we can use Arduino, Raspberry Pi, ESP232 for various applications like aerospace, IoT, wearable devices. All the applications are available. For example, here we are having a vehicle display system that it is especially used for EVs. So this is the front panel, what we are seeing in the Flux.AI tool. The front panel is split into three parts. One is our library functions where the objects or circuit elements are present, and another one is nothing but the design place like a breadboard or PCB board. Here we are having a chat with Copilot. Copilot will guide how the circuit can be implemented from the component selection to connection to schematic to PCB. All the connections given by the Copilot. Here we are having two knobs. One is for macro screening, it is zooming of the circuit, and another one is for the Copilot. So now I can ask Copilot about the question, finding the issues, explanation, create a block diagram, component, compare the components. Instead of if I use a 1K resistor, what is the other component can be selected, connect the components via wire connections. All these things are available in the Copilot scheme. The same, this is for schematic design. The same schematic can be converted into a coding, and the coding will be converted into a PCB. The PCB is available in two dimension 2D and 3D. Normally 2D is available for our view and 3D is also available. If we need grid, we have grid, otherwise we can remove the grid. Once the circuit is simulated, the schematic is converted into PCB and then that will be shared to the, here we are having a share option, share. The design link will be sent to the people who can view the circuit or can modify the circuit. All can be done and that will be saved in our library function. Whenever we open our login, we can get the same circuit. Now we move on to design our own circuit. Now initializing, get the 3 screen. If I want to create a voltage follower circuit, now I start, ask the question from the Copilot. Want to create an voltage follower circuit list out the components. The Copilot is the AI which want to create a voltage follower circuit. What are the components? So Copilot will think, the AI will think and give the list of components. It will not give a direct circuit, it will give only the components which can be used for the design of circuit. So here you see, to create a voltage follower circuit which is known as a unity gain buffer, we need an operational amplifier LM731, power supply, connecting wires, input signal source, load resistor, and how the connections to be carried out with the above component. For example, if I want to connect from this, we can operational amplifier LM741. So we search here op amp LM741. So here we are having a op amp. So we drag the component and the resistor we need 1 kilo ohm. So we can drag this. We see the value of resistor is 1 kilo ohm. If I want 10k kilo ohms, the same resistor 10k, the value will be entered. If I want to connect ground, once if we know the symbol, we can easily connect the components. The ground is here. just drag